Hello my dear students and welcome to my Easy Maths class. Today's topic, area and perimeter of quadrilaterals. All of you know that there are various types of quadrilaterals. That could be parallelogram, that could be rhombus, that could be trapezium, beside rectangle, square, etc. etc. Okay. So the very first thing, that the most important thing is you have to remember the formulas. Always you have to keep the formulas in your mind. Okay, what is given? The adjacent two sides of a parallelogram are 12 centimeter and 15 centimeter. So this one ABCD being a parallelogram and 12 centimeter, 15 centimeter, two adjacent sides. The distance between two smaller sides are 7.5 centimeter. We have to find out the distance between two longer sides. Okay. The very first thing is area of parallelogram. Area of parallelogram is base into height. Okay. Let distance between smaller sides, distance between longer sides be h centimeter. So this one is h centimeter. Okay. Now smaller sides are AD and BC and the distance between them is say DE. Okay. Therefore, area of parallelogram is equal to base into height. Here it is 12 into 7.5 square centimeter, because all of you know that area of parallelogram is base into height. Here base is the smaller side because it is given, which is 12 centimeter and height is 7.5 centimeter. So area becomes 12 into 7.5 square centimeter. Okay. Now we can find this area of the same parallelogram in another way. How? We can find the area of this parallelogram considering the longer side as base. Okay. Again, area of parallelogram is equal to base into height, but this time base is 15, height is h square centimeter, both being the area of same parallelogram. So we can write, therefore we can write 15 into h is equal to 12 into 7.5, or h is equal to 12 into 7.5 by 15. Therefore, answer is coming as, so the distance between two longer side is, the distance between two longer sides is 6 centimeter, and this will be our answer. Okay. So in two ways we have found the area of parallelogram. After getting the area in two ways, we can equate them because ultimately the parallelogram is same. Okay. So here area of parallelogram is equal to base into height, where base is being considered as the smallest side, right? And here area of parallelogram is equal to base into height, where base is being considered as the longest side and height being 8 centimeter. So area becomes 15h. By the problem, 15 into h is equal to 12 into 7.5. You can do one thing, you can keep all the calculations at the very last to do. That will help you immense. Okay. So after few cancellations, the height have been found as 6 centimeter. Okay. I will be back with another very good problem. Here is another very good problem. Please go through the problem very carefully. Each side of rhombus and square are equal. There are one rhombus, one square. Okay. The length of diagonal of square is 40 root 2 centimeter. Okay. The ratio of length of diagonals of rhombus are 3:4. We have to find the area of rhombus, right? So here ABCD be the rhombus and PQRS be the square. Let each side of square be a centimeter. So this one is A, this one is A, this one is A, this one is A. Similarly, this one is A, each side being A. Okay. And next important point is two diagonals. All of you know that two diagonals of rhombus bisect each other perpendicularly. Okay. So what is given? The first point given is, after considering each side of rhombus as well as each side of square as A, what data have been given? Diagonal of rhombus is given as 40 root 2. So therefore, diagonal of square. So therefore, diagonal of square is equal to A root 2, that is equal to 40 root 2. So therefore, A is equal to 40. Okay. So diagonal of square, A root 2 is equal to 40 root 2, therefore A is equal to 40. So each side have been found as 40 centimeter for square and for rhombus. Okay. Now what is given? The ratio of length of diagonal of rhombus are 3:4. Now I am considering, let length of diagonals of rhombus are 3x centimeter and 4x centimeter respectively. Okay. And all of you know that diagonals of rhombus bisect each other perpendicularly. So 4x becomes 2x and 2x and 3x becomes 3x by 2 and 3x by 2, right. So this one is, the point intersection is O. Therefore, from triangle say COD, we can write using Pythagoras theorem, CD square is equal to CO square plus DO square. Therefore, A square is equal to 3x by 2 whole square plus 2x whole square. It means A is 40 square is equal to 9x square by 4 plus 4x square, that is 25x square by 4. So 5x by 2 whole square. Therefore, 5x by 2 is equal to 40. So x is equal to 40 into 2 by 5, that is 16. Now x becomes 16. Therefore, diagonals are 3x and 4x. 3 into 16, that is 48 centimeter, and 4 into 16, that is 64 centimeter. Therefore, area of rhombus is equal to half into product of two diagonals. It becomes 1536 square centimeter, and this one will be our answer. So try to understand, this problem is a bit lengthy. Why it is lengthy? Because data given for the square, from that square all of you know that diagonal of square means side root 2. So from that we have found the side as 40 centimeter. So side 40 centimeter means each side of square and each side of rhombus becomes 40 centimeter each, right? Now the question of diagonals of rhombus arises. All of you know that diagonals of rhombus bisect each other perpendicularly, and ratio given as 3:4. Now considering diagonal of rhombus as 3x centimeter and 4x centimeter, 3x centimeter and 4x centimeter, okay, they are being bisected, so it becomes 2x 2x, it is 3x by 2, 3x by 2. Now triangle COD being right angle triangle, we can easily implement Pythagoras theorem. So using Pythagoras theorem, we have found CD square is equal to CO square plus DO square, means A square is equal to 3x by 2 whole square plus 2x square. Ultimately, x is found as 16 centimeter. Now the length of diagonals have been found. One is 3 into 16, 48 centimeter, another 4 into 16, 64 centimeter, right? Now area of rhombus is equal to half into product of two diagonals, which is half into 48 into 64, that is 1536 centimeter squares. Okay. So okay, my dear students, please go through these problems very carefully, and during our next class I will show you another set of very good quadrilateral related problems. Okay, till then, goodbye.